To get started, why don't you plot the solution to the inequality 3x minus 5 is less than 7 on this number line over here. You can drag around the dot, you can drag the arrow to make it point left or right, and you can click this button to switch between an open and closed dot. And click over here if you'd like to review. Nicely done. Solving inequalities is just like solving equations. To solve this one, you can first add 5 to both sides. The 5's on the left cancel, so 3x is less than 7 plus 5, or 12. Next, we can divide both sides by 3, and the 3's cancel, which means x is less than 12 over 3, or 4. So all values of x less than 4 are solutions to the inequality. Now in this lesson, we'll look at inequalities with negative coefficients, like this inequality where x has a coefficient of -1. So let's try solving this inequality 2 different ways and see what we get. First, let's solve it by adding. So to get rid of the minus sign in front of the x, we can add x to both sides. So on the left side, the x's cancel, and on the right side we have x minus 3. Next, we can add 3 to both sides. So the 3's on the right cancel, leaving us with x, and on the left we have 0 plus 3, or 3. That leaves us with 3 is less than x, which is the same thing as saying x is greater than 3. Okay, so that's the solution for this inequality. Now let's solve it another way, by multiplying. Another way to get rid of the minus sign is to multiply both sides by -1. So on the left side, these two minus signs cancel, leaving us with x, and on the right side, the minus signs again cancel, leaving us with positive 3. So solving the inequality this way, we get x is less than 3. Now hold on a second. We solved this inequality 2 different ways and got 2 different answers. Over here, we got x is greater than 3, and over here, we got x is less than 3. These can't both be right, so which one is correct? Well, let's take another look at the original inequality. -x is less than -3. Can you identify some solutions? Which of these numbers down here can you plug in for x to make this inequality true? Right. 1, 2, and 3 don't work. 4 and 5 are solutions because -4 and -5 are both less than -3. So keeping in mind which of these numbers are solutions, which of these 2 options appears to be correct? Is x greater than 3 or less than 3? Exactly. So the correct solution is x is greater than 3. And that means we messed up over here somewhere. We actually stumbled onto a rule about inequalities. Whenever you multiply or divide an inequality by a negative number, like the -1 over here, you actually have to flip the inequality sign. So as soon as we multiplied both sides by -1, to keep solving this inequality, we have to turn this less than into a greater than. And so the correct solution is, once again, that x is greater than 3. Try another example. Solve the inequality -2y is greater than or equal to 10, and don't forget about this rule. Excellent! To solve this inequality, you can divide both sides by -2. And because we divided by a negative, the greater than or equal sign flips around and becomes a less than or equal sign. Then the -2's cancel, and 10 divided by -2 is -5. So the correct answer is indeed y is less than or equal to -5. Next, try solving this inequality. -4b plus 17 is greater than -7. Nicely done. So we can subtract 17 from both sides, and the 17's on the left cancel. That leaves us with -4b is greater than -7 minus 17, or -24. Then we can divide both sides by -4. And again, dividing by a negative turns the greater than into a less than. The -4's cancel on the left, and the negatives also cancel on the right. That leaves us with b is less than 24 over 4, or 6. So as you correctly found, b is less than 6. Now it's time for you to solve and graph inequalities with negative coefficients. First up is this inequality. Negative 4x plus 3 is greater than or equal to 9. So first solve this inequality and then graph it over here. And feel free to ask for a hint if you get stuck. Nicely done! You remembered to flip the sign when dividing by a negative, and you got x is less than or equal to negative 1.5. Next, try solving this inequality. Negative x over 2 is less than negative 1. This one you can solve by multiplying both sides by a negative number. Precisely. Again, you flipped the inequality sign and found that x is greater than 2. Okay, last one. 7 is at most negative 3x plus 1. First, turn this sentence into an inequality, solve it, and plot it over here. Suppose I tell you that x plus y equals 7. And I also tell you that y plus 3 equals 2x minus 2. This is an example where you have two equations and two unknowns, the variables x and y. Two equations and two unknowns is a common situation in algebra, and most of the time there will be exactly one value of x and one value of y that satisfy both of these equations at the same time, making them both true. But finding those values of x and y can be very tricky. But let's go ahead and try. So to begin, pick one of these equations that we'll look at first. Okay, great. X plus y equals 7. We'll hold on to the other equation down here. So first, try solving this equation for y in terms of x, or click down here if you'd like to review how to do this. Right, saying x plus y equals 7 is the same thing as saying that y equals negative x plus 7. So now let's take a look at our two equations. So our top equation tells us what y equals. It's negative x plus 7. And our second equation has a y in it. Well, we can replace this y with a negative x plus 7 because you just found that this y is the same thing as negative x plus 7. And now let's focus on this second equation. There are no more y's in this equation, just x's. So now try solving this equation for x, or click down here to review. Excellent! So x equals 4. So if x equals 4 and y equals negative x plus 7, try plugging 4 into this top expression to solve for y. Precisely, negative 4 plus 7 equals 3, so y equals 3. And we've done it. We started with these two equations, x plus y equals 7 and y plus 3 equals 2x minus 2, and we solved for x and y. The only values that solve both of these equations at the same time are when x equals 4 and y equals 3. Let's double check our work by plugging in 4 for x and 3 for y. So this x is 4, and this 2x is 2 times 4, or 8. And this y is 3, and this y is also 3. Do these equations work? 4 plus 3 is indeed 7, and 3 plus 3 certainly equals 8 minus 2. They're both 6. So this was the correct solution. Those numbers worked out pretty nicely. The solutions were whole numbers. Next, let's try a messier example that will involve fractions. So if a minus 2b equals 3 and 5b equals 4a plus 1, try solving these equations for a and b. This is tough, but give it a shot. And if you need some help, click down here. Wow, incredible work! Looks like you've really got the hang of solving two equations with two unknowns. Sure enough, a equals negative 17 thirds and b equals negative 13 thirds. At this point, let's quickly write down the steps we took to solve two equations with two unknowns, like these two equations from the first example. First, we picked an equation, like the top one. Then you solved for one variable in terms of the other, like y in terms of x. or you could have solved for x in terms of y. You still would have gotten the correct answer. Then you should plug the expression you get into the second equation and solve for one of the variables. For this example, you found that x equals 4. Finally, you can plug that answer into any of your equations, like this one here, to solve for the second variable. These are a lot of steps, so try to remember the reasoning instead of just memorizing them. The key is writing one of the variables in terms of the other and plugging that expression into the other equation. Okay, let's look at one last example, which is a fun kind of problem that's often given on standardized tests. Suppose Alan is 25 years older than Beth, and in 10 years Alan will be twice as old as Beth. Can you figure out how old Alan and Beth are right now? The trick to these kinds of questions is using this information to set up your two equations with two unknowns. So try writing those two equations and solving them for the ages of Alan and Beth. If you need some help, just click down here. To get started, take a look at these three equations. Which of these has no solution? And to review equations with no solution, click down here. Well done! So this equation has no solution. For any value of b that you pick, the right side of the equation is always 2 more than the left side, so these expressions can never have the same value. And recall that other equations, like this one here, have all numbers as solutions. For any value of k that you pick, 2k plus 3 will always equal 2k plus 3. Most equations have one solution, but these are equations to watch out for that have no solution or where all numbers are solutions. In this lesson, we'll look at cases like these, but with two equations and two unknowns. So here are two equations with the variables x and y. Try solving these equations or click down here to review. Solving simultaneous equations is tricky work, so feel free to ask for a hint if you need one. Excellent! So for both of these equations to be true, x must equal 2 and y must equal -1. Okay, so let's look at two more equations. Y minus x equals 3 and 2x equals 2y plus 5. When solving two equations with two unknowns, a good first step is to pick one of the equations, like this one, and solve for one variable in terms of the other. So try solving for y in terms of x. Right, saying y minus x equals 3 is the same as saying that y equals x plus 3. So let's look at our two equations again. So now we know what y equals in terms of x, and we have a y in the second equation. So let's replace that y with x plus 3. So 2 times y has become 2 times x plus 3 in parentheses. We can simplify this expression by distributing the 2. So 2x equals 2x plus 6, and we still have the plus 5 over here. Adding 6 and then 5 is the same as adding 11. So here's our equation for x. 2x equals 2x plus 11. Try solving this equation for x, and click over here if you think this equation has no solution. Exactly, there's no solution here. The right side of this equation is always 11 more than the left side, so these two expressions can never be equal. And that means these two equations, y minus x equals 3 and 2x equals 2y plus 5, have no solution. Next, take a look at these different pairs of equations. Which two of them have no solution? For each pair of equations, try solving for one of the variables. If you get an equation with no solution, that means the pair of equations has no solution. This is a challenging question, so feel free to ask for a hint if you need one. Nicely done. So these two sets of equations have no solution. There are no values of x and y that you can find that will make these two equations true at the same time. And the same goes for these two equations over here. No values of a and b will make them both true. Next, take a look at these two equations. Y minus 3x equals 4 and 6x plus 5 equals a times y. For a specific value of a, these two equations have no solution. Can you figure out that value of a? If you're not sure, click down here and we'll figure this out together. Excellent work! There are no solutions when a equals 2. One way to see this is to solve the top equation for y in terms of x by adding 3x to both sides. The 3x's on the left cancel out, so y equals 4 plus 3x. Then you can plug in the 4 plus 3x for y in the second equation. So 2y becomes 2 times 4 plus 3x in parentheses. Finally, distributing the 2, you get 6x plus 5 equals 8 plus 6x. The right side of this equation is always 3 more than the left side, so this equation has no solution. That was a tricky question, so nicely done. Okay, let's look at one last pair of equations. Y equals x minus 3 and 2x minus 6 equals 2y. We already have one variable expressed in terms of the other, so let's plug in x minus 3 for y in the second equation. And so 2y becomes 2 times x minus 3 in parentheses. So now we have an equation that's just in terms of x. Which of these is true about this equation? Does it have no solution, exactly one solution, or are all numbers solutions to this equation? Precisely, all numbers are solutions. If we distribute the 2, then this equation becomes 2x minus 6 equals 2x minus 6. Both sides are exactly the same, so any value for x will make this equation true. 2x minus 6 always equals 2x minus 6. So then for these two equations with two unknowns, any value of x can be a solution. X could be 0, x could be 7, or x could be negative 2. For these different solutions, find the corresponding values of y that solve both these equations. For example, we said x could equal 0 in these equations. Well, if that's true, then what must y be equal to? Exactly. When x equals 0, y must equal negative 3. So this is one solution to the pair of equations up here. Meanwhile, x equals 7 and y equals 4 is another solution that satisfies both of these equations at the same time. And x equals negative 2 and y equals negative 5 is another solution. For any value of x, you can always find a value of y that will make both of these equations true. So to summarize, with two equations and two unknowns, just like for one equation with one unknown, we have three possibilities. There could be exactly one solution. There could be no solution. Or there could be many solutions. And here are equations you saw in this lesson that fall into these various categories. So one more thing. In a later lesson, you'll see what each of these three cases means, but graphically. It turns out that each of these equations can be represented as a line on a graph. So this line might represent 3x plus y equals 5. This line represents y minus x equals 3, and this line is y equals x minus 3. And the lower equations also represent lines. This is the line for 2y plus 1 equals x minus 2. This is the line for 2x equals 2y plus 5, and this is the line for 2x minus 6 equals 2y. And here's the best part. You can find the solutions for these equations at the intersections of the lines, where they cross or overlap. So these two lines here intersect at a single point, so there's one solution to these equations. These two lines are parallel, meaning they run in the same direction and never intersect. So these equations have no solution. And over here, these two lines are the same. They lie right on top of each other. So they have many, many points in common, meaning these equations have many solutions. Crazy, right? So stay tuned for this graphical approach for solving two equations with two unknowns.